Welcome back, guys. Still with teacher Edward taking you through applied mathematics under the same topic called mechanics, and then we are looking at the topic components and resolving of resultant forces. So previously we looked at how we get forces at a point which are parallel and perpendicular. So when you have forces in horizontal, you sum them when they are moving in the same direction. When they are in the different direction, you subtract. Then now I want us to get resultant forces due to points which are indifferent or which are having different magnitude and different angle for action. So we say if you have 2 point charges, 2 point forces, R and S are concurrent at a point, the resultant force we get the resultant force by resultant force F is got by R plus S. That's when they are on the same line and then they are in the same direction. But if they are in different direction, come R minus X. So today we want to look at the resultant force for a body which is from having different direction. This is our body forces, and then one is going this side, this one force R, this one is force S. So they are acting at an angle star. So this drawing, we can draw it as our force, which is this one, and then we put it here, and then since we know this angle as theta, this one become our force S, this one become our force R. So where do our resultant force act? Our resultant force will act along this line. From vector calculus, it will act along this one. That's it when we are going to find force by vector addition. So implying that you move from this point to here and then you go up to R. But also someone can say, no, for me I'm just taking straight from point S up to point R. So this one becomes our resultant force F. So how do we get resultant force F? From cosine rule, we said that our resultant force F from F squared, this one, let us name this one maybe to be points, point O, point A, point B. Then this one is still point O. We have shifted this one to here. This one is still point O, A and B. Then how do we find the angle? This angle, if you shift this point to here, which is in the same direction as this one, so to get this angle here, since angles on the straight line is 180, here you shall get 180 minus star. So this angle will be 180 minus star. So that's how we are getting that angle. So we know that from cosine rule, or from sine rule, from cosine rule, which we will look at in paper 1, our OB squared is equals to OA plus OA squared plus OB squared minus 2AB. 2OA and the OB minus 2OA OB sine cos of theta. That's how we calculate this one. So, using that cosine rule, that's what we are going to use. This one become 2 into OA then times the OB. So here what is our OB? Our OB is F squared equals to our OA, which is force S squared plus OAB. It is not OB, it is AB. AB, which is R squared minus 2SR cos of theta. Why are we using cos theta? From here, cos of 180 minus theta is the same as minus cos of theta. So that's the identity we use. So from here, we shall have our F squared equals 2. You take square root, both sides, square root, both sides. This one becomes S squared plus R squared minus 2SR cos of theta. That's how we shall be calculating our resultant force, because this one will cancel with this, which is F equals to root of S squared plus R squared minus 2SR cos of theta. So this is the equation for finding the resultant force. This is how we shall be calculating resultant force, apart from the other methods we have seen. So today this is what we are going to look at, and then that's how we are going to do it. So we look at a given example. Since we said that force must have both magnitude and direction, our star is given by tan of theta equals to R out of, since this one is the one taking, our setup was here, we had something of this type, other going this side, and then we had our S, which is here. So our star is given by, this one can come in vertical, so it is opposite of adjacent, which is R out of S. So our star is given by tan up of R out of S. R out of S. This one is our star. So that's how we shall be calculating star for all the values, for all the forces. So now we go in the real applied mechanics. The other one was just introduction. So what you should note this force, and you should note the direction of forces where they are applied. That one should be noted seriously. So the next thing, we have already looked at if a force is perpendicular to the other one, how we get it. If a force is perpendicular to one force, then we use the other method of F equals to square root of that one force squared plus that second force squared. Take for example, we say that if a force is 1, if it is a 1 force which is F, this force is having both horizontal and vertical component here, which is F sine, horizontal component here of theta, which is F cos. This one become F cos theta. This one become F sine theta. Then they go in that direction. This one is when you're having two vertical components. So the horizontal and you resolve it perpendicular and horizontal. But when we have two forces, we use this method. So take note on that one. Two forces, this method. One force, we use this one. We resolve it perpendicular, and then after we get the direction. So let us look at the other example. Example 1. So we are going to be somehow quick. It's saying a particle is acted upon is acted upon by two forces, full stop. Six Newton force act on it, act in direction of northeast. And 7 Newton force act in direction of 26 degrees south east. That's our example number 1, which we are having. We have example 1. We have a particle is acted upon by two forces. 6 Newton force act in the direction of northeast, implying if this one is our particle, so this one is our bearing. Northeast means it is in the middle of northeast. So this one become 45. And then this one is our north, this is our east, this is our west, south, this is our west. So this is force of 6. And then I've said force of 7 act 26 degrees. Force of 7 act 26 degrees south east, implying it is 26 degrees as you come from south to east. So what do? If we take this one, we extrapolate this one, and we extrapolate this one, where will the resultant force act? If we extrapolate these two, we extrapolate this, and then we extrapolate this one. Our resultant force will act in this direction. In that direction, the direction between the two will be alpha. So let us use it as star. So these are two forces. Actually, we can even sketch it out. We have had these two forces. Now that we have force A and force B. One is going this side and one is coming this side. A resultant force will act in such a way that it goes towards the greater force, which is 7 7 Newton. So this one is coming that side, and also this one is going this side. The resultant force, they will be in this direction, which is F, due east. Then that one is the question. Then they are saying calculate the resultant force. So we said that our resultant force from this longest, for a triangle, we are going to use this one. Our magnitude, let this one be point O, this one be point B, this one be point C, this one be point D. We said point OC squared is given by point O, which is OA. We say let this one be point O, this one A, this one B, and the other one C. Point OA squared plus point OB squared minus 2 OA into OB, cos of star. So our OC is force squared equals to OA, which is 6 squared, plus OB, which is 7 squared, minus 2 into OA 6, OB 7 cos. What is our angle? What is our angle? What is our angle? Our angle is the angle between the forces from here up to here. But we know between the force and the resultant is star. So the forces is the angle here we have. This angle is must have 180. But if you subtract 180 from, you get 180 minus 45, and then minus this one, we shall get 180 minus 45 plus 26. This one is 180 minus 71. This one will get 109 degrees. That is our angle, which we are going to use angle star. This one was angle alpha. Star, star, star. So this is 109 degrees. So here we shall put cos of 109. So we get the resultant force from here, which is F under square root squared equals to 6 squared, which is 36, plus 7 squared, which is 49, minus 2 times 6, 12 times 7, we get 84 cos of 109 under square root. This one will cancel, then our resultant force will become, we use a calculator to solve of this one. We shall get 36 plus 49 minus 84 cos of 109. It is under square root of that one. We are getting the resultant force is 36 point. Yes, this angle, yeah, this one is positive and this one is positive. It was because the other one we used the cos and we found it as negative. But since this one is positive, we are going to add the 2, and then we shall see 36 plus 49 plus 84 cos 109 under square, we get 57.65 under square root. This one we get 7.59 degrees. it is 57, square root of 57.65 is 7.59. This is force Newton, force. Then we need to get the alpha. Say that our alpha is given by tan arc of force out of, now which force, what is the opposite? The opposite becomes this force out of adjacent, which is 6 out of 7. So this one becomes 6 divided by 7. Tan arc of that one, which is, tan arc is giving us 40.6. 40.6 degrees. So you try to confirm your calculator if the angle we are getting is the same. If the angle we are getting is the same angle, so it is acting in that direction. So that's the answer. So let us see ourselves in the next example.